In this video, we are looking at the equation of a line. Here we've got three graphs that we're going to draw. So the first graph is y equals x plus 2. We've got a table of values that we've been given, and we are going to use the x coordinates to find the y coordinates. So the equation says y equals x plus 2. So we can substitute our x values into our equation, substitute our x coordinates into our equation to find our y coordinates. So I'm going to start with the positives. So y is x plus 2 when x is 2. Y is 2 plus 2, and 2 plus 2 is 4. When x is 1, y will be 1 plus 2, which is 3. When x is 0, we've got 0 plus 2. When x is negative 1, it's negative 1 plus 2, which is 1. And negative 2 plus 2 is 0. So this should form a nice straight line. It goes up in 1 every time. So let's plot these coordinates. So we've got the coordinates negative 2, 0. Negative 2, 0, negative 1, 1, 0, 2, 1, 3, and 2, 4. And we can join them up with a straight line. And that is our line. For the next one, we have the equation of 2x plus 2. So y is equal to 2 times x plus 2. And again, we're substituting in the x coordinates to find the y coordinates. So 2 2's are 4, plus 2 is 6. Again, I'm starting with a positive just because you're less likely to make a mistake with positive numbers. Substituting in positive numbers is easier than substituting in negative numbers. 2 1's are 2, plus 2 is 4. 2 0's are 0, plus 2 is 2. And you can see a pattern. 2 negative 1's are negative 2. Negative 2 plus 2 is nothing. And 2 negative 2's are negative 4. Plus 2 is negative 2. And again, we've got our coordinates. So we can plot them on negative 2, negative 2. Negative 1, 0, 0, 2, 1, 4, and 2, 6. So let's join these up with a straight line. And that is our second graph. And the last one, y equals 3x plus 2. So the y coordinate is 3 times the x coordinate plus 2. So we've got 3 2's, which is 6, plus 2 is 8. 3 1's are 3, plus 2 is 5. 3 0's are nothing, plus 2 is 2. 3 negative 1's make negative 3. Negative 3 plus 2 is negative 1. And 3 negative 2's are negative 6. Negative 6 up to is negative 4. So we've got negative 2, negative 4, negative 1, negative 1, 0, 2, 1, 5, and 2, 8. And again, we can join these up. So join these up with a straight line. And that is our graph. So what do we notice about all of these graphs and all of these equations? So we can see that they've all got a plus 2, and they all cross at y equals 2. So we call that our Y-intercept. So this number on the end of an equation, the number by itself, not the one with the x, the other one, tells you where it crosses the y-axis. So if we had y equals 3x minus 4, that will cross at negative 4. It will cross the y-axis at negative 4. If we had y equals 2x plus 7, that would cross the y-axis at 7. So that is our y-intercept. Okay, 3 more graphs to look at here. So the first graph is the graph of 2x plus 2. So again, let's complete the table of values. So we're substituting in the x values into the equation to find the y values. So 2 2s are 4, plus 2 is 6. 2 1s are 2, plus 2 is 4. 2 0s are 0, plus 2 is 2. 2 negative 1s makes negative 2. And negative 2 plus 2 is nothing. And 2 negative 2 is negative 4. Plus 2 is negative 2. So we've got the same thing that's going up in every time. That makes it a straight line. So we've got negative 2, negative 2, negative 1, 0, 0, 2, 1, 4, and 2, 6. So there's our straight line. And we can join it up. And that is our graph. For the next one, we've got the equation of y equals 2x. So y equals 2x. You might notice that this one's got no y-intercept. It's got no plus or minus a number at the end. And that means it's going to cross at 0. So if it's got no y-intercept, that means, well, the y-intercept is 0. So let's complete the table. So y is equal to 2x's. So 2 2s are 4. 2 1s are 2. 2 0s are 0. 2 negative 1s are negative 2. And 2 negative 2s are negative 4. So let's plot these on. Negative 2, negative 4. Negative 1, negative 2. 0, 0. 1, 2. And 2, 4. And we'll join them up again with a straight line. So there is our line. And the third one, y equals 2 times x plus 4. So 2 2s are 4, plus 4 is 8. 2 1s are 2, plus 4 is 6. 2 nothings is nothing, plus 4 is 4. 2 negative 1s make negative 2. Negative 2 plus 4 is 2. And 2 negative 2s make negative 4. And plus 4 makes 0. So we've got negative 2, 0. Negative 1, 2. 0, 4. 1, 6. And 2, 8. So again, join them up with a straight line. And there is our graph. So what do we notice about these graphs? So these graphs we call parallel. They're parallel. They're all running in exactly the same direction. They are parallel lines. And what do you notice about the equations? So they've all got a 2 before the x. They've all got 2x. They've all got the same number before the x. And we call that the gradient. So we can say all of these lines have got a gradient of 2, which means they go up in 2s. And you can see from each of the tables of values that they were going up by 2 every time. So for every 1 you go across on the graph, it goes up by 2. We call that the gradient. So we can say that the equation of a line is y equals mx plus c. So m, whatever number, m and c are just numbers, and whatever number m is, we're going to call the gradient, how steep the line is, and whatever number c is, we're going to call that the y-intercept. So this is the equation of a line where m and c are numbers. So if we had y equals negative 2x minus 4, we'll say there's a gradient of negative 2. So it will be going down in 2's. Every one it goes across, it'll be going down 2. And it will cross the y-axis at negative 4. If we had y equals 5x plus 1, it will have a gradient of 5. So for every one it goes across, it will go up 5. And it will cross the y-axis at 1. So this is our equation of a line. So we've got the gradient and the y-intercept. So here's some examples. Write down the gradient and the y-intercept of the graph. Y equals 5x plus 3. So the equation of a line is in the form y equals mx plus c, where m is the gradient and c is the y-intercept. So for our first example, we can see that the m, the gradient, is 5. I'll call it m. We could write gradient. And the c, the y-intercept, is 3. For the second one, we've got y equals x minus 7. So there's no number in front of the x, but we can say there's 1x. Having no number in front of x is the same as having 1x. So it's got a gradient of 1 and a y-intercept of negative 7. And in the third one, you can see that it's been written the other way round. So the one with the x is still the gradient. So the one with the x is the gradient. So the gradient here is negative 6. We've got negative 6x minus 6x. So we can say the gradient is negative 6. And c is this 2, which is a positive 2. So it's 2. Okay, 3 of these for you to try. So give these a go. The first one, write down the gradient and the y-intercept of y equals 4x plus 1. So it's got a gradient of 4. It's got 4x. It's a gradient of 4 and a y-intercept of 1. The second one, it's 5x, so it's got a gradient of 5, but there's no plus c, there's no y-intercept. It's crossing the y-axis at 0. So c is 0. And the third one, again, it's been written the wrong way round, or the other way round. The gradient is the one before x. So the gradient is the one before x, which is negative 2, and the y-intercept is 8. So for every one it goes across, it goes down 2, and it's crossing the y-axis at 8. And another example, this time we've got equations that have not been written in the form y equals mx plus c. So we can't tell what the gradient and the y-intercept are by looking at them, but if we rearrange them and get y by itself, make y the subject, then we can find the gradient and the y-intercept. So how can I get y by itself in this equation? So I want to get rid of 2x. So to do that, I can take 2x away from both sides. So if I take 2x away from the left side and the right side, both sides are the equal sign, I'll get y minus 5 equals negative 2x. But then to get y by itself, I can plus 5 to both sides. So y is going to be negative 2x plus 5. So now it's in the form y equals mx plus c. So I can write down that the gradient is negative 2 and the y-intercept is 5. And the second example, again, it's not in the correct form, so we can find the gradient and the y-intercept by making y as a subject, getting y by itself. So if I take 2x away from both sides, I've got 2x plus 3y is equal to 1. I want to get y by itself, so take 2x away from both sides, which gives us 3y is equal to 1 minus 2x. I could have written these the other way around and put minus 2x plus 1. But it doesn't matter which way round. You just need to know that the gradient is the one with the x. But I haven't got y by itself. I've got 3y. So how can I get y by itself? So to get rid of a times by 3, we do the opposite of timesing by 3, which is dividing by 3. So I want to divide by 3. So I'm going to divide everything by 3, divide both sides by 3. So I write 1 minus 2x over 3. How can I divide this by 3? Well, I can divide both of the terms individually by 3. So I can say 1 over 3, which is 1 over 3, and 2 over 3, which is 2 over 3. So I've got y equals 1/3 minus 2/3 x. So what is the gradient and what is the y-intercept? The gradient is minus 2/3. It's the thing with the x, and the y-intercept is 1/3. Okay, 2 for you to try, so give these ones a go. Question 1, again, write down the gradient and the y-intercept, or find the gradient and the y-intercept for 3x plus y plus 6 equals 0. So we want y by itself, so take away 3x from both sides. So we'll get y plus 6 equals negative 3x, and then take away 6 from both sides. So we get y equals negative 3x minus 6. So the gradient is negative 3, and the y-intercept is negative 6. For question 2, we've got 4x plus 5y equals 2. Again, we need to get y by itself. It needs to be in the form y equals mx plus c, so we can write down the gradient and the y-intercept. So let's take 4x away from both sides, which will get us 5y equals 2 minus 4x. And then we're going to divide by 5. So we're going to divide every term by 5. So that will give us y equals 2/5 minus 4/5 x. So what is the gradient? What is the y-intercept? The gradient is the one with the x, so that's minus 4/5. And the y-intercept is 2/5. To finish up, we've got 2 questions. Pause the video, give them a go, and press play when you're ready for the answers. Question 1 says write down the gradient and the y-intercept of the graph of y equals 3x minus 4. So the equation of a line is in the form y equals mx plus c, where m is the gradient and c is the y-intercept. So we can just look at this graph and say 3 is the gradient is 3, and the y-intercept c is negative 4. Question 2, write down the equation of a line parallel to y equals 3x minus 4. So lines that are parallel have the same gradient. They go in exactly the same direction. That means they've got the same gradient. So any line at all with the same gradient to y equals 3x minus 4. So the gradient is 3. So anything with y equals 3x. So any y-intercept at all, apart from minus 4. So y equals 3x plus 2, or plus 3, or plus 4, or plus 5, or minus 10. So as long as it's got the same gradient, a gradient of 3, you can write down that line.